So in previous lecture, we saw the different types of the windmills and the different points related to the introductory points to the wind turbines. What are the horizontal axis wind turbine? What is the horizontal axis wind turbine, etc. Now, the next point is wind data and its parameter. Now, this wind data is very important whenever we design one particular wind turbine, or before that, even before the designing of the wind turbine or the installation of the wind turbine, we have to carry out the survey, which will include the most important point, that is the wind data. Now, wind data means what? The velocity of the wind or the speed of the wind at that particular location. Because if you want to install the windmill or the wind turbine at the particular location, we should know what is an average velocity of the air or the wind at that particular location. Because whenever if you want to generate the power from windmill, it will require minimum average wind speed. Okay, if that speed is very less than 2 meter per second or less than that, in that case we cannot produce the electricity, because that is not enough energy is present at that particular point or the location. So for that, we must have the wind data of that particular location of the previous 1 or 2 years. So we can understand, or we can decide whether we want to construct the wind turbine or the windmill at that particular location. As we know, the wind velocity on Earth's surface is varying location to location. It is particularly depends upon the geographical location of that particular site. Okay, so if you want to install the windmill at that particular site, we must know what is an average wind data or the yearly wind data. We should know the details of the wind speed and wind direction, etc. Then we can able to install, or the if you we can decide whether we have to install the wind energy or the windmill at that particular location or not. Okay. Now, what is the wind data? Wind data is particularly consists of the wind velocity, because that is the most important factor, right? So if wind velocity is very high, in that case, that wind will contain the more and more energy, and we can extract the more and more energy from the wind. So the wind data primarily consists the wind velocity, and we know the wind velocity is a vector quantity. It is not a scalar one. Means it is having the magnitude plus it is having the direction also. So that wind velocity data, we should know before any installation or selection of the site, because that is the primary factor we have to consider. Now, wind velocity is a vector quantity. It will having the magnitude and the direction, and that wind velocity, the values of wind velocity of the previous 1 year or that particular month, if we know that particular data uh, has been observed, and we can say it has been monitored during that particular certain time period, and we will study, first of all, we study that particular wind velocity data, because the velocity of wind or the speed of the wind is going to be changed by second to second. Okay, so if you want to install one windmill at that particular location at any particular site, we first of all study its wind data, and that wind data is initially consists the wind velocity. Now, by conversion, the value of this horizontal component of the wind velocity, which has been tabulated, sometimes we are using the graphs to show that particular tabulated data. The measurement of wind speed, we can use different types of the instruments. Most of the time, we are using anemometer, that is curved type of anemometer. You can see here in this particular diagram, curved type of anemometer, where it will contain this cup. Okay, these are called as a cup. Okay, it is having the semi-spherical shape, and there are four curves are there. Okay, and this one is the axis. This particular one is axis, and it has been connected to the small generator. Okay, it has been connected to the small generator. So what will happen if the air from any direction, it will strike on this particular cup, okay, and it will apply some force, and at that in that case, these curves are going to be revolve around this axis. Okay, so likewise, when these curves are revolve around the axis, it will connect it to generator and it will generate some signals. So that's how we are measuring this particular velocity of the air. Okay, Now that velocity has been tabulated and studied. We can plot that velocity data on one particular graph and carry out the analysis. Now, the wind velocity at any particular location usually varies rapidly and continuously, day by day, or when during nights also, the wind velocity is going to be changed. So that variation we have to study, because if you want to install one particular wind turbine or the windmill, where first of all we have to calculate its capacity, means how much amount of capacity that particular windmill should consist. So for that, you must know how much amount of wind energy present at that particular location, right? So in that case, to find out the wind energy, we should know what is the velocity of that air. Okay, because if we know the velocity, we can easily calculate the energy contained at that particular the energy contained by that particular wind. Okay, so as we know, when air is passing or the wind, it will contain most of the kinetic energy, because it is in the motion. So it will contain the kinetic energy. And if you know the speed, if you know the velocity, we can easily calculate the kinetic energy. Okay, so based upon the available energy of the wind, we can calculate the capacity of windmill that we have to install at that particular location. So for that, we should know the wind data, or we must have the wind data. It will primarily having the wind velocity as I mentioned. So if we know the wind velocity for previous 1 year or previous 2 years data, if we have, then in that case we can consider, we can find out how much amount of capacity, or what should be the capacity of the windmill we have to install at that particular location. So for that, we are using the different components to measure the velocity, different components to tabulate that data, store that data. Okay, and we can use the different methods to carry out analysis of that stored data. Now that data is, again, there are different types. Okay, this is one type of data. You can see it will be seen that there will be a tremendous variation. Okay, but at actual, if you find out the average of this particular data. Now first of all, this one is data is time versus wind speed, which is one of the example. You will see the velocity of that wind is going to be changed by time to time or by second to second. Okay, and you will see there is a large variation of the wind velocity. And if you find out the average of this particular around that particular time period, in that case you will see that average is near about 6 meter per second, right? So we know the average velocity of that particular of that particular wind velocity. In that case, we are going to consider the average velocity is 6 meter per second. Okay. Now the energy contained by that particular wind, means yearly, if we consider, or for whole day, that wind will contain the energy which is near very equivalent or near to the 6 meter per second meter of velocity. Okay. So from here, how to calculate the energy? Just using the kinetic energy formula, 1/2 mv square. Okay, so 1/2 mv square. By using this particular formula, we can calculate the energy contained by that particular wind speed, or by that particular wind. Okay, just a minute. There is network connection. I will just reconnect. Okay, am I audible? Is my voice audible? Because there is power failure at my side. Am I still audible? Can anyone please reply?
Yeah.
Okay, yeah. Okay, so you can see this is known as a wind data, right? And for we can observe this wind data for year, for months, etc. And by using that wind data, we will find out the average velocity or the average speed of the wind at that particular location. And from that, we can calculate the available energy. Okay, that one is the available energy at that particular location. So Based upon the available energy, we can calculate the or we can find out the capacity of the wind turbine that should be installed at that particular location. If the average velocity is less, in that case we cannot install the high capacity windmill, right? In that case, we should require low capacity windmill, which is having low capacity because the available energy is low. So these particular data is very important. First, before going for any installation or during the site selection of the windmill installation, in that case, we have to analyze this data. This is the most important step. Okay. Now you will see there is a variation, right? There will be a fluctuation during time to time, and from that we have to first of all find out the mean or the average, and then we can going to calculate the particular capacity. Now you will see this is our India, and this is our India. You will see in the particular map, and you will see there are different stations are there. Okay, these particular arrows you can see, these are the stations. Okay, and at that particular location, the wind velocity has been calculated, or it has been observed. Sorry, it has been observed for all over years. Okay, and if you connect, just I will show you. So we will go near about Pune. So particularly it is that the one particular station, it is situated in the Mahabaleshwar, and you can see if you select this particular location, you will see station ID is 43111. Station name is Mahabaleshwar. State is Maharashtra, and the regional meteorological department or the center is Mumbai. And the wind direction at that particular location, it is in the northwest direction. Okay, because the velocity is a vector quantity. It is having the magnitude. It is having the direction, right? So the wind direction, it is in the northwest direction. Okay, and it is having the speed, it is the 3 meter per second. So this is the actual speed, it is the live reading of that particular wind. Okay, so like that, if you want to install the wind turbine, first of all analyze or the observe all the data all over the year, okay, which will contain the wind speed, wind direction, etc. And based upon that, you can find out how much should be the capacity of the windmill, or what should be the design of the windmill, in which direction we have to install it, or if you want to install the horizontal axis wind turbine or the vertical axis wind turbine. So it is depends upon the site selection. That is, these steps are included inside the site selection of the site selection. Okay. Similarly, you will see here there will be another station which is near about Nashik. You can see again the wind direction. It is in the west direction. Okay, it is only in the same direction of the west direction, and it is having the speed 4 meter per second. Similarly, all over the India, you will see different types of different stations are there, and at that particular station, the wind speed has been measured. So this one is the wind data that has explained. This is the wind speed duration curve. Okay, similar to the load duration curve. So we are going to present that wind data in the form of graphs. We can use the different types of the graphs. You can use the pie chart, and you can also use the tabulated data at the particular point. This particular data, it is of the load duration curve for the Kandla station, which is situated in the Karnataka, in the Andhra Pradesh. Okay. Now, the most important point regarding the wind energy, that is the power from the wind and Bitz model. Okay, this one is the important point. So we know the wind will consist the kinetic energy, and we are going to convert that kinetic energy into the electrical energy. Now that conversion happen two times. Okay, first of all, the speed, sorry, first of all, the wind will consist the kinetic energy, right? Now that wind will impact, or it will pass through the windmill. Now windmill will convert that kinetic energy of wind, this kinetic energy of the wind, and it has been converted first of all into the mechanical rotary energy, because windmill directly not going to convert into the electricity. Okay, first of all, those when those wind is passing through the blades, it will exchange the energy, it will give the energy to the blade, then blades will rotate. So that kinetic energy of wind, it will convert it into the mechanical rotary energy. And the same mechanical rotary energy, it is given to the generator. And that finally, that generator will convert that mechanical rotary energy into the electricity. So that's how the energy it has been converted. Okay. First of all, it will convert it into the mechanical rotary energy and then into the electrical energy. Now, for your concern or for your study, this conversion is most important because this will contain the design and the study of the windmill. This particular conversion contain the study of generator, right? Because it is totally depends upon the generator efficiency. Now, this particular conversion is most important whenever we study the windmill because that is the primary function, converting the kinetic energy of wind into mechanical rotary energy. Okay, so for that we know what is the kinetic energy. We know already know the formula of kinetic energy. The kinetic energy contained by that particular wind, it is equal to 1/2 mv square or mu square. U means the average velocity of the wind. Okay, so this is simple formula of kinetic energy we can use. Now, if you want to calculate the power, power means what? It is the energy available per unit time. Okay, so power is equal to dE upon dt. So we are taking the differentiate with respect to the time. So you will get the power. In that case, the formula will be 1/2 m dot. Here we are using m dot. This m dot means mass flow rate. Here it is only mass kg. Here it is a mass flow rate. M dot is there means kg per second. Okay, so that is the difference. So it will give you this power formula, that is 1/2 m dot u square. Okay, that will give you the amount of power generated by that particular wind turbine. Okay, so from that whole power, only small portion of the wind can be converted into the electrical energy because there is a whenever we convert these two type of conversion happen, there will be a conversion efficiency is there. Okay, because we cannot convert 100% of that particular energy into the electrical energy. This is the power contained by the wind. Okay, this one is the wind power. Okay, this is called as a wind power because this much power that particular wind will contain. Now we cannot convert this 100 that particular power 100% into the electrical energy because there are some mechanical losses are there, there are some generation losses are there, and also if you want to convert whole power into the electrical energy, in that case what should be the condition? Consider there is this one is the uh, turbine, okay, or this one is the windmill. Okay, the wind is flowing from front side, right? Now if you want to that particular wind will contain this much of power pw, right? Now this wind will pass through that particular blades and it will giving the power some amount of energy to the blades. Now if you want to extract 100% of that energy, it is not possible because in that case, how to extract 100% of energy? If we extract 100% of energy, then velocity of wind after it passing through the blades or the back side of the blade will be the zero. Okay, means after this blade, velocity of air should be zero. Okay, so this is not desirable condition. If the velocity of wind after the blades or the back side of the blade is zero, in that case that particular flow will stop. Okay, so it is not possible to convert 100% of energy into the useful energy or into the electricity. Okay, it is not possible. So that particular study has been done by the Bitz. This is the name of the scientist, and that study has been done by the Bitz. Okay, now the power contained by the wind we can easily calculate by using this particular formula. If we know the area, swept area, and the density of the air at the particular point, we can find out the power. Now, how to convert? How much power has been converted? That we have to calculate. Okay, now the power. Before that, you must know these particular two particular factors. Okay, power coefficient and T speed ratio. Now, power coefficient means what? It is the ratio of actual mechanical energy which is taken out from the rotor or from the windmill divided by the power contained by the power contained by the wind. Means it will give you the amount or the fraction of energy which is converted into the mechanical energy. Means this particular uh, conversion. Okay, means this kinetic energy or this wind will contain 100 kinetic energy, just considering, then how much amount of that wind energy it has been converted into the mechanical rotary energy, that is given by that particular power coefficient. So this value of this power coefficient is again varies from 0 to 1. Okay, and it will give you the amount of power, amount of the fraction of power, wind power converted into the mechanical power. Okay, now we have to calculate this power coefficient. If you know the power coefficient, you can easily calculate the mechanical output power by just measuring the wind power. Okay, so this CP, which is very similar to the we can say the coefficient of discharge in the case of flow measurement devices. Okay, so this CP, which will deal with the converting efficiency in the first stage, that is from kinetic energy of the air, kinetic energy of the wind to the mechanical rotary energy. And it is defined as the actual capture mechanical power by the blade to the available power in the wind. That is the power coefficient. Okay, this one is the important factor. And second factor is the T speed ratio, which is indicated by the lambda. It is denoted by the lambda, and it is the ratio of speed of blade tip to the free stream wind velocity or the free stream wind speed. Okay, means this is the particular wind turbine. Okay, it is the speed of the tip of the blade and the wind speed. Okay, that is known as the tip speed ratio, lambda. Now these two are very important whenever we have to understand the Bitz model, because what Bitz stated, it stated that whatever will be the design or whatever will be the energy contained by the wind or whatever will be the velocity of the wind, we can extract only 0.593 percent, or sorry, 59.3% of the wind energy into the mechanical rotary energy, and that is known as the Bitz limit. Okay, or we can also call this as a Lanchester Bitz limit for the power coefficient. Means what? The maximum possible conversion efficiency, it will be the 59.3%. It will be 59.3%. Okay, we cannot achieve more efficiency than the 59.3%. Whatever will be the design of that turbine, or whatever will be the design of the blades, whatever will be the design of the different systems, we cannot convert more than this particular wind energy into the mechanical rotary energy. Okay, so or indirectly we can say in the terms of power coefficient, that power coefficient maximum value will be 0.593. Okay, the maximum possible value of the power coefficient is a 0.593. We cannot achieve more than that. So that is the limit which is derived by the Bitz, and it is totally depends upon the different experimentations on the different types of the windmills, different types of the models, etc. Okay, so the variation of this power coefficient with T speed ratio and the other parameter has been indicated in this particular graph. You will see this is the variation of power coefficient with respect to the tip speed ratio. So you can see as tip speed ratio initially, this power coefficient, the value of power coefficient will be increased. After some time, that coefficient power coefficient value will remain constant, and maximum it will goes up to 0.593, not more than that. So that one is known as the Lanchester Bitz limit. Okay, and you will see the different graphs with respect to the value of gamma. Now this gamma is again the ratio of drag coefficient and the lift coefficient. Okay, so that is the formula. So by using these particular graphs and these particular Lanchester bits will derive this particular limits of the conversion efficiency. Okay, now this has been done by a different large amount of experimentation, and after that those draw this particular they come to this particular conclusion. Now the calculation of this CD is most important in the case of wind turbine, because it gives you the actual how much amount of energy will convert it into the mechanical rotary energy or useful energy, we can say. So calculation of this CD is important. For that, there are different types of empirical formulas. You can see this one is one of the empirical formula, that is Cp is equal to 16 upon 27 into exponential minus 0.3538 into lambda raised to minus 1.2946. Okay, that will directly gives you the value of Cp if you know the value of lambda. Okay, similarly, using another formula, you can also calculate the value of Cp more precisely if you know the coefficient of drag and coefficient of lift. In that case, the value of Cp will be 16 upon 27 into exponential minus 0.3538 into lambda raised to minus 1.2946 into minus epsilon into lambda. Okay, so by using these empirical formulas, you can calculate the value of Cp. If you know the value of Cp, we can easily calculate how much of energy it has been converted into the useful energy. Okay, now and for that you must know what is the Bitz limit. Okay, this particular limit, it has been calculated by the Bitz model, Lanchester Bitz limit. It will known as a Lanchester Bitz limit, and its value is near about 0.593. That is the maximum possible conversion. Okay, we can compare that one with the Carnot efficiency or the Carnot engine, because if we compare that one, Carnot engine will have the maximum possible efficiency. Similarly, here the maximum possible conversion efficiency, it is the 59.3%, not more than that. That is the ideal condition. All other all other actual windmills which is having the less uh, uh, power coefficient than the 0.593. It is generally in between 0.35 to 0.45. What are the windmills? It actually we are installed in the different locations. The maximum conversion efficiency we got, it is near about 0.45. Okay, but it is less than 0.45. It is in the range of 0.35 to 0.45. Okay, so that is the power from wind and Bitz model. This one is the important question is there in assignments. Just explain what is meant by what is the power from the how much power that wind will contain, and what is the Bitz model, what is the Cp, what is the lambda, and the what is the maximum velocity, maximum value of the Cp. You can also draw this graph and explain the variation of the CD with respect to the lambda. Okay, so that's it. That's it for today's lecture. The remaining only one point is there, that is the site selection or the factor affecting the site selection of the wind turbine power plant. Okay, so that we are going to complete it, or just I will share the recorded session of that particular point, because we have to cover the remaining chapter, which will contain the other renewable energy resources. Okay, it will contain the biomass energy, it will contain geothermal energy, then ocean energy and tidal and wave energy. Okay, so that's only one point is remaining, that is the selection of the site selection and the operational issues. Okay, so I will provide you the recorded video of that site selection and the operational issue. So that will be the end of our wind energy chapter. These two chapters, unit number 5 and 6, those are very small chapters. If you know the basic idea of those type of energy resources, you can easily write down all the questions, or you can easily solve all the questions. There will be no any numerical on unit number 5 and unit number 6. There will be only numerical on unit number 4, that is only based upon angle of incident. I will separately share you the video. I will share you the video, recorded video of that numerical, how to solve the numericals and different types of the numericals. Okay, so that will be the end of today's lecture, and indirectly the end of this particular chapter, unit number 5, wind energy. Okay, so we will stop here. If anybody have any questions, you can ask now.